Good morning, learners, and welcome to this class. We continue with our stream of classes on land degradation. Remember, last week we talked about soil salinity. In the previous week, we talked about soil degradation. Today, I want us to look at soil acidity, which is also another problem related to land degradation. In this class, I want us to understand what are acid soils, their classification, their occurrence, the sources of these soils, the processes involved in their formation, and their characteristics, their impacts, and also how they can be managed. What are acid soils? Usually, when you refer to a soil as acidic, it has a low pH and has got relatively high amounts of hydrogen cations and aluminium cations. That is what we consider a soil to be acidic. It has low pH, high amounts of hydrogen and aluminium cations. But when we look at it, their classification is that ultra-acidic soils have got a pH of 3.3 or less. Extremely acidic soils have got a pH between 3.5 and 4.5. Very strong acidic soils have got a pH of 4.5 to 5. Strong acidic soils have got a pH of 5.1 to 5.5. Moderately acidic soils have got a pH of 5.6 to 6, and slightly acidic soils have got a pH of 6.1 to 6.5. But what are the sources of these acids in the soils? Some of the sources include rainfall, the parent material, fertilizer application, plant root activity, decomposition of organic matter, the climate, the vegetation, the topography, and some of human activities or interferences. We will look at each one of these sources and how they influence the soil so that they can be acidic. Rainfall. Usually, rainfall occurs in excess in hilly areas. The excess rainfall causes the leaching of basic cations. Once the cations that are basic or alkaline have been leached, the soil becomes slightly acidic, that is a pH of 5 or below. This creates what we call as a base unsaturation, and this promotes the increase of the hydrogen and the aluminium cations, making the soils continue getting worse from being alkaline to being basic. The other cause of soil acidity is parent material. Usually, some parent material consists of acid rocks such as granite, gneiss, and quartz, or what we refer to as silicon oxide. When the rocks lack bases, they produce acidity in the soil after decomposition and weathering. And this acidity is in the form of oxalic acid, tricylic acid, and silicic acid, and these are the ones that promote the soils to become acidic. Usually, the reasons for the development of acid soils from parent material is because the soils do not have enough capacity to buffer, or what we refer to as a cation exchange capacity. They do not have enough capacity to buffer enough buffering capacity. That is, they do not have enough cations to neutralize if it is extremely acidic, to neutralize the pH so that it goes up. If it is extremely basic, to neutralize so that the pH goes down. They also have got less adsorbed cations, and the parent rock in this case usually have a simple percolation, a simple composition, and is quick for water to infiltrate through. Hence, the processes of elevation and elevation are very active in such material. The other reason as to why we get acid soils is as a result of fertilizer use. And fertilizer, usually what it does, it introduces what we call as ammonium sulfate and ammonium nitrate. And we come back to home. What are the common fertilizers we use? The most common fertilizers used in farming is CAN, what we refer to as calcium ammonium nitrate, and DAP, diammonium phosphate. These introduce nitrates in the soil, and once they are introduced, they cause through the processes of nitrification and ammonification, they increase the acidity of soil or reduce the amount of bases in the soil, and hence the soils become acidic. How does this occur? Once you introduce ammonium nitrate and nitrates, whether you are using CAN or DAP, what they do is that they assist in the formation of hydrogen cations, and this also results to what we call as the soil organic nitrogen, and this causes the pH of the soil to get lower, and as a result, through the processes I have mentioned of ammonification and nitrification, the soils become acidic. The other reason as to why we get acid soils is plant root activity. Usually, some plants will produce organic acids, and once they produce organic acids, at the roots, we are supposed to have a balanced pH so that the plant can uptake water. But the production of organic acid increases the rate at which the hydrogen ions are formed compared to the basic cations, and hence acidity. The other reason as to why we could have acidity in the soil is the decomposition of organic matter. Usually, the process of decomposition requires microorganisms, and microorganisms release carbon dioxide as a byproduct. The, the reaction between carbon dioxide and water in the soil, either in the soil or by the plant roots, produces what we call as carbonic acid. This is also a contributory factor to soil acidity. Another reason why soils are acidic is as a result of climate. Usually in humid areas, soils are naturally acidic. And the reason why they are naturally acidic is that, unlike the case in tropical areas where we are, is that evaporation is less than precipitation in humid areas. Remember, one of the reasons why we said tropical soils or soils of arid areas, what we refer to as aridisols, are saline, is because evaporation exceeds precipitation. In this case, it is the other extreme. In humid areas, evaporation is so low compared to precipitation, and as a result, acids are formed. And I have said this usually occurs in humid areas, and it is a natural process. The other reason why we have acidity in soils is as a result of the vegetation cover. Usually, in temperate regions, we have got vegetative covers, particularly conifers. And these conifers, they lack alkali substances, and on the other hand, they have cumulative organic acids, or what we refer to as fulvic acids or humic acids. These result to soil acidity. Also, in coastal areas and areas that are marshy, as a result of less decomposition, fulvic acids and humic acids are in very high amounts. Hence, the result to acidity of the soils. And that is why I want to mention what I have been mentioning all along. Anything, for instance, in the case of soil organic matter, or what we refer to as soil cover, which could be in the form of vegetation cover, it is required for soils to be in good condition. However, in excess, it has a harmful effect. And we are saying in this case, if you use a lot of vegetation cover, the likelihood of organic acids, what we refer to as fulvic and humic acids, is likely to occur, and hence your soils can be acidic. The other reason as to why we get acid soils is as a result of topography. In slopy areas with good drainage conditions, acidic soils develop. And they develop because once the drainage occurs, it drains away or takes away most of the basic cations. It leaches them off or runs them off, and as a result, what is left is acidic soils. There are also some of the human activities or human interferences, as we saw in the case of saline soils. that can cause acidic soils. And these include the improved drainage in submerged areas or areas that are known to be marshy or wetland areas. There is also the use of ammonia called fertilizers, what I have referred as we regularly use in this country, the CAN and the DAP, because they have got excess ammonia and excess nitrogen, and these have got a way to enhance the process of forming hydrogen cations, and as a result, the soils become acidic. Another human activity that results into acidic soils is the use of industrial waste, or what we refer to as unscientific disposal of solid waste. And in this case, the solid waste is then reused. The waste, the dumping sites or the landfills that have already been dumped industrial waste containing sulfur dioxide are used for farming. What happens is that the presence of sulfur or the presence of sulfur dioxide, usually when sulfur is present, it will react with oxygen to form sulfur dioxide. However, when it is mixed with soils, what happens is that due to the moisture of the soil, they react with the water to form sulfuric acid, and this, in another way, increases the acidity of soils. What am I saying? What I'm trying to say is that we must also be careful of the human activities we engage to improve our soils. We have to do them at a constant, at a considerable rate, not too much, not too little, so that we can make our soils not acidic. But what are the processes that lead to soil acid formation? There are two processes, what we call as lateralization and partialization. Remember, we had partialization as one of the reasons why soil is formed. And let us look first at lateralization. Usually occurs in subtropical and tropical regions. And in this case, the leaching of the parent rock that consists of sandstone, schists, basalts, and granite results in the formation of laterites. And laterites are soils that are rich in aluminium and iron. And the aluminium and the iron are acidic in nature. And what they do is that they exist in the clay, minerals, and due to leaching processes, in the process of soil formation, as we discussed earlier on in this class, they form acids. These acids are easily leached, and they can either move up or down the soil horizon, and eventually they result to acid soils. Apart from aluminium and iron, some of the other compounds that can be leached in the process of forming of laterite soils are calcium, magnesium, sodium, and potassium. But when we look at the process of partialization, is that this occurs in humid areas, unlike the case of laterites that occur in tropical areas. It involves the mobilization of the precipitation of dissolved organic materials, that is, soluble minerals such as aluminium and iron, and these usually are leached from the A horizon to the B horizon. Remember what we had, the A and the B horizons in our first class, that the A horizon is the top horizon, is the top swell, and the B is the subswell. Once the aluminium and the iron cations are leached, what forms is acidic swells, and this is usually formed in moist, cool, acidic conditions of humid areas, where the parent material mostly consists of silicon oxide, or what we refer to as quartz. Remember what I said, the problem with silicon oxide is that it forms what we call as siliceous acids that are very strong, and they make the soils acidic. So, soils of tropical and subtropical regions become acidic as a result of lateralization, while those of humid regions become acidic as a result of fossilization. But what are the characteristics of acidic swells? Acidic swells can have either physical, chemical, or biological characteristics. But let us look at the physical features. Number one is that they have got a light texture. They are highly permeable. That is, they are able to allow water to pass through, but they have got poor water holding capacity. They have poor cation exchange capacity, and this is as a result of the fixation of the aluminum and the ammonium and the nitrate, the ammonium and the nitrates. And there is also, they have got poor organic matter. Some of the chemical features of acidic soils is that the base and their bases are unsaturated. That is, they have got bases, yes, but they are not available in the available cationic or anionic form for the soil or for the crop. They have got more anions compared to the cations. Then they are active and they have got the potential to cause soil acidity. Most of them consist what we refer to as toxic aluminum levels, and at low pH they have got high levels of aluminum, iron, manganese, zinc, copper, and cobalt cations, while the magnesium, the calcium, and the phosphorus is in less concentrations. Some of the biological features of acidic soils is that the fungi they have is in higher concentrations compared to the bacteria. But what is the problem with the fungi being in higher concentrations compared to the bacteria? One of the reasons is that the fungi are likely to cause root disease. Another reason is that most of the microorganisms in the soil are in the form of the ones that are used to make the soil tilled or the soil structure are in the form of bacteria. This means that if you have got a higher fungi population, then the ability of the soil to make soil organic matter or improve its structure is diminished, and there is a likelihood of causing root diseases. Then the other characteristic of acidic soils is that the rate of decomposition of biological material and the rate of nitrification and mineralization are reduced. And why are they reduced? Because the amount of bacteria that can survive is is limited. What are some of the impacts or the effects of soils that are acidic? Just like the characteristics, the impacts of acidic soils can be categorized into three. They can be physical, chemical, or biological. Physical: in strongly acidic soils, the potential for reduced vegetation is very high. That is, most of these soils do not have enough vegetation cover. Remember what we said are the effects of not having enough vegetative cover is that the vulnerability of the soils to wind and water erosion is very high. Also, another physical effect associated with acidic soils is that the low pH soils are loosely held together. Remember, we have said the loose texture of the soils that are acidic is one of the physical characteristics identifying them. But what is wrong with having a loosely held together soil? It has got various effects. One of them is that the soil will not be able to hold enough water, and hence crop survival will be diminished. Another reason is that the soil is vulnerable to erosion or losses by wind. And another reason is that if it is not able to hold enough water, it is able to leach a lot of water, and in the process of leaching, it reaches what we call as basic cations, and as a result, the acidity characteristics become worse. Look at this. This is an example of the physical appearance of a strongly acidic soil. That is, look at its structure. Even look at it. Even the survival of vegetation is limited. Some of the chemical effects of acidic soils is that with a low pH, there is an ion fixing capacity. And once the ions are fixed, I do not know whether you understand what is anion fixation, is that once the anions are fixed, they cannot be accessible in their ionic form. And remember that the plants can only access the anions in their ionic form. But if they are fixed, it means they are there, but they are not available for plant uptake. Then there is also what we call as a decrease in the availability of phosphorus, and this is as a result of anion fixation. That is, usually once the soils become acidic, they form salts, and these salts are not soluble. Once they are not soluble, you will find that you will have a salt composed of phosphates, but it is not soluble. Hence, it cannot be availed to the plant. Remember, when you are looking at micro and macronutrients, phosphorus happens to be one of the macronutrients that is required in high amounts by the crop for survival. If it is not there, it means the productivity of crops has also been deterred. There is also what we refer to as aluminum toxicity as a result of high acid soils. And in this case, it happens as a result of fixation where aluminium and phosphorus combine to form aluminium phosphates that are insoluble, and hence they are there in high amounts, but they cannot be used because they cannot be accessed by plants. There is also what we call as calcium and magnesium level deficiencies. And remember, and also what we call as molybdenum deficiencies. These are some of the micronutrients that are required by some crops. There's also of restriction of nitrogen fixation in legumes. And once nitrogen fixation has been deterred, remember we have been saying of the aspect of crop rotation, that you rotate cereals and legumes to enhance the process of nitrogen fixation and the formation of nitrates for the soils. If these nitrates are not formed, then it means that the crop will not be able to access nitrogen. And if the crop is not able to access nitrogen, it is not able to access phosphorus, it is not able to access calcium, magnesium, and molybdenum, then it means it is losing a whole deal of micro and macronutrients, and ultimately the crop productivity will be lowered. Look at this. This is a representation that shows you that how acidity can affect, or how the pH, the acidity or the basicity of a soil can affect the availability of nutrients. And when you look in this table, a case example like magnesium and calcium is that their availability is in very low amounts at low pH. But once the pH increases, they are in very high amounts. The same case applies to nitrogen, sulfur, and potassium, that at low pH, they are available in very low amounts compared to high pH. But look on the other extreme in the case of iron, manganese, copper, zinc, and aluminium. At low pH, that is acid soils, they are available in very high amounts. But at near neutral pH, they are available in very low amounts. The case of molybdenum and phosphorus, at acidic pH, they are available in very low amounts, but as the pH draws to neutrality, they become highly available. What I am trying to demonstrate here is that the pH of soils, whether it is acidic or basic, some of the nutrient availability is affected. The biological effects of soil acidity is that low pH usually leads to reduced growth of microorganisms, and these microorganisms, as we have mentioned in previous classes, are essential for the cycling of nutrients, that is the nutrient cycles, and also for the construction of and decomposition processes of soil organic matter. Also, in acidic soils, symbiotic relationships are influenced negatively. That is, the amount of microorganisms or the flora and fauna that survive in soils is also limited. That is why acidic soils have got reduced native vegetation. Also, some of the macroorganisms that are found in soil and help in the cycling of soil or soil in soil processing or soil formation, such as the earthworms and some of the insects, are not able to tolerate high acids or structuring of the soils that results as a result of increased acids. If their survival is limited, then it means the ability of your soil to become productive is also limited. Thank you. I hope you have learned, you have understood what some of the causes, some of the effects, and the way we classify soils so that they can be said to be acidic. In our next class, I want us to look at the management of these acidic soils. What is it that we can do to ensure that the pH, or the low pH associated with acidic soils, is increased so that it becomes to a level that is near neutral, where most of the nutrients are able to be in their ionic form available for crop uptake. Thank you.